Okay, welcome back. In the last video, we were talking about how do you know when you have produced a rate of output that maximizes profit? Well, what you've got to do is you've got to look at each unit's marginal revenue. Remember, marginal revenue is a change in total revenue when you sell one more unit. Marginal cost is the change in total cost when you produce one more unit. So we're doing this on a unit by unit basis. And you've maximized profit where the last unit you produced has a marginal revenue equal to the last unit's marginal cost. So in other words, you want to know the impact on how each unit impacts profit. So if you produce a unit and profits go up, you produce another unit. So you keep expanding the rate of output until profits are maximized. So if the last unit increases the level of profit, then you increase the rate of output. If the last unit reduces the level of profit, then you reduce the rate of output. So I want you to understand that we're not looking at an entire range of output. We're looking at unit by unit. So in other words, we're not focusing on all 5 units in this case. We're focusing on, let's say, just the 5th unit. What did the 5th unit contribute to revenue? What did the 5th unit contribute to cost? So let's take an example. Let's look at the 1st unit. What if the 1st unit had a marginal revenue of $9 and a marginal cost of $4? Well, that's like saying profits went up by $5 because the first unit generated $9 in revenue and the first unit generated $4 in cost. Profit went up. So great, let's produce another unit. So now we apply the same test to the 2nd unit. Well, can you see how marginal revenue stayed the same? Because the demand curve is flat for a perfect competitor, meaning every time you sell one more unit, you sell it at the market price, which is $9. So marginal revenue is not changing, but marginal cost is changing. So you see the profit per unit has fallen, but that doesn't matter because total profits has increased. So we definitely want to produce a 2nd unit. So what about the 3rd unit? As you can see, the 3rd unit total profits did increase because the 3rd unit contributed to profits by $2 more. Revenue is 9, marginal cost is 7. And the same goes for the 4th unit. Total profit increased by $1. Now, when we get to the 5th unit, we see that total profit hasn't changed. And we don't want to produce the 6th unit because we know that by then, marginal cost will be greater than marginal revenue. So we know that we've maximized profit once we've gotten to 5 units. And now we could see this graphically. We could see that between 0 and 7.4 units, marginal revenue is above marginal cost. When we get to 7.4 units, we now see marginal revenue is equal to marginal cost. If we increased output to Q2, we could see Q2's marginal cost is right here, but Q2's marginal revenue is right here, so profits would have dropped, so we would have to have reduced output. 7.4 is when we've maximized it. So let's do this mathematically. If I've given you a total cost curve here, and I've given you the price, we could figure out profit maximization by setting MR equal to MC. Well, what is marginal revenue? Marginal revenue is the change in total revenue when you produce one more unit or sell one more unit. Well, price and marginal revenue for a perfect competitor are the same. So when I give you the price of a good in perfect competition, I'm also giving you marginal revenue. So marginal revenue we've already figured out. What about marginal cost? Well, marginal cost is the change in total cost when you produce one more unit. Now, mathematically, that's the first derivative of the total cost equation. Now, you say, oh my goodness, derivatives, calculus. Well, I've posted some primers on how to take a derivative of an equation like total cost on the course site. So please review that. So first, question A, find the equilibrium price and quantity. Well, we've already know what the equilibrium price is, 44, but how much do we produce? Well, once we figure that out, we're going to figure out our profit or loss. So what we're going to do is take the first derivative of the total cost equation to calculate our marginal cost. And what we're going to do here is the the first derivative, this is going to go changed into 4. This, we're going to bring this 2 over here, multiply it by 2, that's going to bring 4, and then we're going to subtract 1 from here, and that's going to change it 4q to the first, and that's what you see here. So marginal cost is 4 plus 4q. Now all we have to do is set marginal cost equal to marginal revenue, and that's 44 marginal revenue equal to marginal cost, and we solve for q. So we just subtract 4 from both sides, and then divide by 4 on both sides, and we get q equals 10. That's how much we produce. Well, since we have q and we have price, we can figure out total revenue. Total revenue is P times Q. So 44 times 10 is 440. Now what about total cost? Well, I've got the total cost equation, and I could plug in my rate of output 10 in this equation, and that's going to give me my total cost. So you see I plugged in 10 where you see Q here, and my total cost is 240. So 440 minus 240 is going to give me a profit of $200. And that's how you solve this problem. Now, in the long run, it's possible to earn profit if you're a firm in an industry that's perfectly competitive. But in the long run, you cannot, because what's going to happen is firms will hop into this industry looking for more profit. And when they come into the industry, they bring supply with them, and they shift the market supply curve to the right. And that drives down the market price, which drives down your revenues. And basically, economic profits will go away as a result. So, if so many firms hop into the industry and profits, and let's say firms actually take a loss, how do you know when to leave a market, temporarily shut down, or continue to produce and try to minimize your losses? Well, let's take a look at this. This is the supply and demand curve for a industry, and this is going to be for a firm, for a perfectly competitive firm. And you can see this is establishing the market price, and we could see that this is going to set the price for the firm over here. And as you can see, this price is below average cost, which means this firm is taking a loss. Now, what this is going to do is some firms are not going to like this, and they're going to leave the market. When they leave the market, they take supply with them, and it's going to shift the market supply curve to the left. Watch. Firms exit. See how the supply curve is shifted to the left? And now that sets a new market price, which is a little bit higher, and the loss is a little smaller. But still, firms are going to leave. And when they leave, the supply curve shifts over to the left again. And you could see we're going to get back to the long run equilibrium where price is going to be equal to minimum average total cost. And the same could be said, what if price is above above average total cost? You can see here the price is set right here, and since price is above your ATC, see we produce where marginal revenue and marginal cost cross, and you can see at this price it's above our average total cost, so we're earning a profit. Well, that's going to cause firms to come into the market, and when they come into the market, they bring supply with them, and as you can see, it shifts the market supply curve over to the right. We've got a new lower price, so profits are falling, but as long as price is above average total cost, firms are going to enter the market until so many firms have come into the market where it drives price down to, again, minimum average total cost. So this is the long run equilibrium for a perfectly competitive industry. Now, there are some remarkable attractive features in the long run. One, in the long run, price is going to be equal to marginal cost. And now that is a representative of allocative efficiency. Remember, allocative efficiency is producing what people want. Now, why does price equal MC equal allocative efficiency? Well, think of price as the value society puts on a good, and marginal cost as the opportunity cost to society to produce it. If price is greater than marginal cost, that's another way of saying we want more of that product. And if we want more of it, that means we're not producing what people want, so that's not allocatively efficient. Well, if price is less than marginal cost, that means we don't value it as much as the opportunity cost to society, so that means we want less of it. That's not allocatively efficient either. So you reach allocative efficiency when price is equal to marginal cost. Another long run outcome is price is equal to minimum average total cost. Now, this is an example of productive efficiency because when price is equal to minimum average total cost, that means you're producing a rate of output that has the least cost on average, which means it's using the least amount of resources, and that's productively efficient. Now, keep in mind, these are the theoretical outcomes of a perfectly competitive industry. But perfectly competitive industries don't exist. So we don't really achieve this theoretical efficiency. The question is, do we come close enough to achieve allocative and productive efficiency that makes the free market system more efficient than other systems? That's the key. And so when you have a situation where there is inefficiency that's not accommodated for, that's market failure. And so, um, what we'll do is we'll talk more about market failure later on, but I just want to get you an idea how perfect competition theoretically achieves allocative and productive efficiency and how you solve for the profit maximizing rate of output mathematically.